Today I'd like to discuss the idea of a complement a little bit more. One more time, define what it is, but then show how we can use the idea of a complement to actually calculate the probability of an event. Now please recall there were two types of complements. There's a complement of an event, which is simply all the other possible outcomes besides that one event for a given well-defined procedure. And then secondly, there's the complement of a probability. And we find that by simply taking that probability and subtracting that from 1. So please recall, as I've mentioned on an earlier video, that the probability of some event plus the probability of that event's complement, everything else that could happen, must add up to 1. And I also showed you then that we can find the probability of an event alternately by simply finding the probability of its complement and subtracting that from 1. This equation follows from this first one right here. And you may ask, well, okay, that's nice, but I don't really see how I can use that in a particular problem. Well, let me show you exactly how we can use that. The example I want to use has to do with a few cards that I took from a deck of cards. As you can see here, I've got 3 hearts and I've got 5 spades. 3 hearts, 5 spades. What I'm going to do is turn these over, shuffle these real well, mix them up, so I have no idea what's where, and set these down on the table, kind of spread them out, and just randomly, I'm going to pick three of these cards at random. So let's say I pick, this one right here. Here's one. I'm going to set it up here aside. And I pick, let's say this one here. And let's pick this one on the bottom right here. This one right here. Okay? Let me move these other cards out of the way. And take these 3 cards and lay them out here. All right, so here are the 3 cards that I picked. Now, here's the situation. What's the probability that at least one of these, don't know which one, but at least one of these is a heart? Is that likely? Remember, I only had 3 hearts and 5 spades, making 8 cards altogether. Now, what do I mean exactly by at least one? Well, please understand, at least one means one of these is a heart, or maybe 2 of these is a heart, or maybe all 3 of them is a heart. How do we figure this? Well, there's 2 ways. One way is to use a complement, and another way is just to do it directly. Let's actually go through it the harder way by doing it directly. Let me show you really what you have to go through. Now, normally we wouldn't do all this, but I just want you to see it. So maybe you'll appreciate more how we're going to use the complement. So let me set these cards aside, and later on we'll look to see how I did. Okay. Oops. All right. What I want to do is to make a list of all the possible outcomes. Well, since I chose 3 cards, an outcome is simply picking 3 cards. So what are my possible outcomes? Well, let's use an H and an S, H for heart and S for spade to represent that. One possible outcome is that the first card is a heart, and the second card is a spade, and the third one is a spade. Okay? The next possible outcome is that the first one's a spade, the middle one's a heart, and this one is a spade. You say, but yeah, that's the same as that. Well, no, that's really a different outcome. Next possibility is the first one's a spade, the second one's a spade, the third one's a heart. Okay, let's continue. Next possibility is the first one's a heart, the second one's a heart, the last one's a spade. So I'm talking about having 2 hearts now. Okay, so it could be that the first one's a spade and the last 2 are hearts. The third possibility here with 2 hearts is the first is a heart, the last is a heart, and the middle one's a spade. Okay, do I have any of the possibilities left? Yeah, I've got 2 more possibilities. It could be that all 3 are hearts. And I've got one more possibility. It could be that none of them are hearts. So that'd be a spade, and a spade. Okay, now I want to know, of these 8, can you see all 8 of these? No, just barely not. But that's all right, I'll move it. From these 8 different outcomes, which one of these satisfy the event of at least one is a heart? Well, that encompasses these first 7, doesn't it? All of these have at least one heart. So, let's go through and actually calculate then the probability of at least one heart. What we have to do is find the probability of each one of these outcomes. So here we go. The probability of getting a heart followed by a spade followed by a spade. All right? Notice this is done without replacement. So we have to take that into account. The probability of getting a heart, well, there were 3 hearts out of 8 cards. So that's probability of getting a heart. The probability of getting a spade, well, there are 5 spades out of 7 cards. And then the last one being a spade, well, now there's only 4 spades to choose from out of only 6 cards. Okay, so it becomes the fractions 3/8 times 5/7 times 4/6. We could reduce that, but we can just go ahead and multiply that together, and you'll find that that is equal to a grand total of, rounding to 3 decimal places, 0.179. Okay, let's do the same thing for here. The probability of getting a spade the first time, well, there's 5 spades, so that's 5 out of 8. Of getting a heart, well, there's still 3 hearts, but only 7 cards to choose from. And the last one is getting another spade, so now there's only 4 spades out of 6 to choose from. Multiplying 5/8 times 3/7 times 4/6 also turns out to be exactly, or at least rounded to the nearest 3 decimal places, 0.179. You might guess at this point, since we still have 2 spades and a heart, that the probability of third is going to be the same. And you can go ahead and write this out yourself, but if you just have to believe me for now that it's also going to be 0.179. Now let's go to a different situation where I've got 2 hearts and 1 spade. The probability of getting a heart the first time is 3 out of 8. The probability of getting a heart the second one now with no replacement is only 2 out of 7. And the probability of getting the spade, there's still 5 spades to choose from, but only 6 cards. 5 out of 6. When you multiply those 3 together, we get approximately 0.089. And you'll find out, since this is also 2 hearts in the spade, I know the different order, but it's still 2 hearts in the spade, this turns out also to be exactly, or to 3 decimal places anyway, 0.089. And this one here, which is 2 hearts in the spade with a spade in the middle, the probability is 0.089. Okay, our last case is the probability of getting a heart and a heart and a heart. Let's see what that is. Well, that's 3 out of 8 the first time. There's only 2 hearts left out of 7 the second time. And there's only 1 heart left out of 6 the third time. When you multiply those together, that comes out to be approximately 0.018. All 7 of these outcomes account for the event at least one is a heart. So if we add all these up, you'll find this adds up to 0.882. So the probability that at least one out of these 3 cards is a heart is approximately, 822. My fault. 0.822. Okay? Is approximately 82%. Okay? Approximately 82.2%. That's the hard way. That's the long way. Let's do it the easy way. The complement of this event is everything else. Everything else is simply this single outcome down here with the three spades. What's the probability of getting 3 spades? Well, the probability of getting 3 spades is 5 out of 8 times 4 out of 7 times 3 out of 6, and that is equal to approximately 0.179. Okay, since this is the complement, I know I can find the complemental probability by simply subtracting this from 1. So 1 minus 0.179 is equal to 0.821. And you say, well, that's really close to what we got over here, but not exact. Well, the difference is, because of rounding, with this much rounding, we're just off just 1,000th. This is really closer to the exact answer. So wasn't that a lot faster than doing all that? Here's where we use the idea of simply finding the probability of the complement event and just subtracting it from 1. Much faster. So hopefully that gives you a better understanding of how we can use the complement to find the probability of an event.